Today we're going to start to talk about separation of variables. And I've talked about how a lot of what we're doing in this semester is undoing the processes that we were doing last semester. And so like our use substitution was undoing the chain rule. This process of separation of variables is undoing the process of implicit differentiation. So that was where we had our dy dx. We had our two variables in the same equation. Anytime there was a y, we took a derivative with y, we had a dy dx, and we separated out the dy dx's, and we had to figure out what dy dx is and solve down. That was implicit differentiation. Now we're going to go the other way. So now we know what dy dx is, and we're going to work backwards to get what the original equation had to be. That's what we're going to end up doing today. So first off, use separation of variables to solve the initial value problem. The first thing we're going to do in separation of variables is we're going to separate the variables. I know. We're going to separate the variables. So that means everything with x is going to go on the right side, and everything with y is going to go on the left side. So first off, I need to multiply by y on both sides to get everything with y on the left side. And then I also have a dx here. Well, that's got an x in it, so it can't be on that side. It's got to come on the other side. So we're going to multiply by dx on both sides as well. I won't show this part of the process every time because you guys know how to manipulate an equation around. But we have y dy on the left side equaling x dx on the other side. And now, since we have an equation with everything with y is on one side and everything with x is on the other side, each side only has one variable going on, then that becomes easy to take some antiderivatives. We're going to take the antiderivative of both sides. So we'll start over with y. Antiderivative of y is 1/2 y squared. Antiderivative of x is 1/2 x squared. And now both of these sides should technically have a plus c on them. But there'd be a constant over on this side and a constant over on this side, so a constant minus a constant would be a constant. And you'll see that happen a few different times. That we're going to try and keep a single constant, a single plus c happening throughout the problem. So if all we're doing to it is taking the constant and changing it to a slightly different constant, and it's still a constant and doesn't have a variable attached to it, then we're still good to just call it c. So we're going to get down and solve this equation for y. So we're going to get y by itself on this equation. So we will do that by multiplying by 2 on both sides. So we have y squared equals x squared plus 2 times a constant. Guess what? It's still a constant. So we're still just going to write plus c. If I take some number and multiply by 2, it's still a number. Then to solve for y, I get to take square root of both sides. And in that case, y equals plus or minus the square root of x squared plus c. So remember, that whenever you take square root of both sides, I need a plus or minus there. We'll take the plus or minus away in just a second, but watch closely. We'll talk about why. Now, we're going to do the same thing we had done with some of these problems in the last chapter, and we're going to solve for c. We're going to solve for our constant. So I'm going to do that by same thing we did in the last chapter. Plug in the point. Y is 2 and x is 1, so that means that 2 goes in for y. And 1 goes in for x. Here's where I talk about my plus or minus. My plus or minus means that I want to know whether I want the positive or the negative answer. Well, it looks like the answer should be positive 2, so I want the positive answer. I can do some fancy stuff to solve it, but hopefully you can look at that and know that c is going to be 3. So y equals positive, we know it's the positive square root, of x squared plus my c we know is 3. And that's my final answer. So we separated out our variables. We got everything with y on one side, everything with x on the other side. Then when we did the antiderivative, we had this plus c here. So we need to get y by itself and solve for y. And then we also needed to plug in our point to get what our constant was, to get what our plus c ended up being. Now, which one of those parts, those last two steps, which one you do first will depend on the problem. So sometimes it'll be easier to get your plus c first and then solve for y. So let me show you what this problem would look like if I solved for c first. Because that's a perfectly valid way to do it. So instead of solving for y first, I'm going to plug in the point first and solve for c so that you can see what that would look like. So going from here, if I were to plug in from here to solve for c, then I would say, well, 1/2 times y is 2 squared equals 1/2 times x is 1 squared plus c. It's going to look slightly different, but the final answer is going to be the same. So watch what happens. 2 squared is 4. Half of 4 is 2. 1/2 times 1 is 1/2 plus c. And so c is 3/2. And so when we follow along here, we have 1/2 y squared equals 1/2 x squared. And then we said plus 3/2. And now I solve for y. I'm going to solve for y the same way I did earlier. I'm going to multiply by 2 on both sides. And all the 2's on the bottom, all the halves go away. And I have y squared equals x squared plus 3. So remember earlier when I did my 2 times a constant was still a constant? Here was what my constant was before I multiplied it by 2. Here's my constant after I multiplied it by 2. It was still a constant, so I could still keep it plus c. So that's the difference in what we solved for c and what c ended up being. But the answer, when I take the square root of both sides, is still going to be y equals the positive square root because the output should be positive. We know that because the y coordinate ended up being a positive 2. It's still going to be x squared, square root of x squared plus 3. And I'm going to get that same final answer. So before I go through the next problem, I want to show you the steps. step-by-step process here. So those of you who are fans of writing down number lists of steps, here it is. Separation of variables. We start by separating the variables. Everything with y goes on one side. Everything with x goes on the other side. That's step one. Step two, take the antiderivative of both sides. So once you've got the variables separated, then take the antiderivative of y on one side, take the antiderivative with x on the other side, and put your plus c. Then we want to get y by itself, plug in a point, solve for c. The order that we do it in is going to depend on the problem. It's going to depend on how easy is it to solve for c, or how easy is it to solve for y before we solve for c. So some of the problems it's going to be easier to do it one way, some of it's going to be easier to do it another. It doesn't matter, we're just going to use whatever's easier. So those are your steps. Pause if you need to write them down. We're going to keep going. dy dx equals y over x. I'm going to do this one really quickly because it's an easy problem. First off, I want to separate out the variables. I want to get everything with y on one side and everything with x on the other. So that's going to require dividing by y. So I get dy over y on the left, and then multiply by dx here, I get dx over x on the right. So now I need to take the antiderivative of both sides. Integrate. Antiderivative of 1 over y is going to be natural log of the absolute value of y equals natural log of the absolute value of x plus c. And so now what I can do, the thing I'm going to do this time is instead of solving for y first, I'm going to solve for c first. Because it's going to make the problem a whole lot easier. Natural log of the absolute value of 2 equals the natural log of the absolute value of 2 plus c. Even if you're struggling with the logarithms, I hope that you can figure out that c is 0. And so that means that the natural log of the absolute value of y equals the natural log of the absolute value of x plus 0. And so when does the natural log of the absolute value of y equal the natural log of the absolute value of x? It's when they're the same. X and y are the same. Y equals x. With one exception. Two things are a problem with natural logs. I don't like negative numbers in a natural log because, remember, the answer to natural log is an exponent. So I'm saying, what exponent can I put there to make it a negative number? None. That's not possible. So I don't like negative numbers, but that's not going to be a problem because I've got my absolute value bars. So we're good to go there. And then the other thing I don't like is 0. I can't say what exponent can I put here to make the answer 0 because that doesn't exist. And 0 is a problem. I cannot have x and y be 0. Everything else works. So that one, it was easier to solve for our constant first. right, we'll look at one more here today, and then we'll be done. This one's tougher. dy over y plus 5 equals x plus 2 dx. Right? I didn't need to move the x plus 2, so it stayed on top. So now when I do the antiderivative of both sides, antiderivative of 1 over y plus 5 is going to be the natural log of the absolute value of y plus 5 equals, antiderivative of here is going to be 1/2 x squared. Antiderivative here is going to be 2x plus c. This time I'm going to solve for y first. And this is where it's going to get complicated, and this is where you need some natural log and exponents trickery here. So here we go. I can rewrite this. Remember, the answer to the natural log is the exponent. So that means this answer over here, the 1/2 x squared plus 2x plus c, is going to end up in the exponent. The base is e. And the exponent is all this stuff on the right side. And you'll notice I got rid of absolute value bars there. I got rid of absolute value bars because e to any power is going to be positive. That's the same thing as saying the natural log of a number should always be positive. Right? No matter what exponent I put up here, the answer should not be negative. So I don't need to worry about absolute value bars because I'm always going to get a positive thing here. All right. Let's subtract 5 from both sides. And then we're going to come over here and the trickery begins. Y equals e to the 1/2 x squared plus 2x plus c. So the problem right now is that the plus c is up in the exponent. It's going to make it harder. And so we're going to use a property of exponents. Property of exponents. You use it when you say 2 cubed times 2 to the 5th. Well, that is 2 to the 8th. How did I get that? By adding my exponents. So in other words, b to the x plus y equals b to the x times b to the y. Right? If the exponents are added up here, I can separate them with multiplication. Or if they're separated with multiplication, I can combine them with addition. So right now they're combined with addition, so I can separate out my part with the constant using multiplication. Here's what that's going to look like. I'm going to separate out e to the 1/2 x squared plus 2x. And then I'm going to separate out with multiplication times e to the c. Minus 5. And the reason that that's helpful, separating out my constant part, is that e to a constant is still a constant. Because e is just a number. So if I take it to the power of some number, I still wind up with some number. Some number times e to the 1/2 x squared plus 2x minus 5. So now we've solved for y, and now I just need to plug in and solve for c. And plugging in and solving for c is going to be a whole lot easier now. So y is 1 when x is 0. So we're going to put in 0 for x. E to the 0, which is 1. And so 1 equals c times 1 minus 5. So c equals 6. So for our final answer, we're going to write that expression, and in place of our c, we're going to put 6 right out in front where our c was. So we're going to do a couple more like this, but the key part of this process is bringing this constant out in front. And that's with our rules of exponents that let us separate out with the multiplication. And knowing that if I take that number and raise it to the power of a number, I still have some number. So that's what lets me put the c out in front. And then it's a lot easier to solve for c. So that's our process. We're going to practice a few more of these over the next couple days. So I will talk to you more then.